So today is going to be a continuation kind of from how we ended our notes yesterday, where we were solving the 1 and 2 step equations. But what we're doing now is we're adding 3 or 4 or more steps in order to be able to solve more complex equations. The good news though, the end goal is still the same. We're still ultimately trying to get the variables by themselves. However, as you have more pieces thrown into the mix, it starts to get a little bit busy and it kind of becomes a little bit more difficult to decide what to address first. So having worked through so many problems before, I've come up with this list, kind of like a checklist. And if you follow it in this order, I would say 98% of the time, it's going to work out in your favor. I say 98% because odds are there's probably some weirdly written equation out there that I'm not thinking right now off the top of my head that probably doesn't quite follow this pattern, but most of them will. So the good news is, as you work on the assignment today, I would suggest having these notes out and available. That way, if you get stuck, you can ask yourself, did I go through and check these things in this order? And if not, hopefully it'll get you unstuck. Also, another thing that I didn't mention yesterday, when it comes to test time, I'm not terribly interested in memorization. I think you will memorize things as you use them more frequently. So what I typically do is I provide either on the board or a reference sheet that you physically have with you at your desk that you can use while taking the test. Now, having said that, it doesn't have the amount of detail that the notes have, but it is a more abbreviated format. That way you're not sitting there thinking, oh my goodness, how am I supposed to memorize all this material? I don't want you to worry about memorization. I'd rather you be comfortable to say that if I looked up these steps, I would know how to use them. And that's what I'll give you for test time. So those steps, we're going to read through them here, but then we're going to see them more in action. The first half of our notes, the examples we work through, we're going to identify each of these individual cases separately. And then as we transition to the back, we'll see what it looks like to have most of these steps apply all at once. They look scary at first because there's a lot of pieces in play. But one of my strongest recommendations I mentioned yesterday is organization, taking your time, writing things down as neatly as you can is going to pay off immensely. Don't try to take shortcuts. Don't say, I don't want to rewrite this same number 3 times until I'm ready to use it because I just don't want to waste my time. It's not a waste. It's going to pay off, and I promise you that. So one thing I do want to highlight here real quick, that it does mention that not every step will be used every time. And that's just because every equation is going to be unique. You can't guarantee that you'll always have parentheses, or you'll always have like terms, or where the variable is always going to end up. But you do need to consider them still until you can safely say that, no, this does not apply for this scenario. So the steps are, if you have parentheses anywhere in your equation, either side, use the distributive property accordingly. Whatever number is nestled right beside those parentheses, go ahead and multiply that into every single term. And that takes care of that. Parentheses will be gone. Second thing you check for, once the parentheses are out of the way, check either side for like terms. Now, another thing here, just a little quick reminder that like terms, we combined a lot yesterday, but like terms must be, I'm going to extra emphasize this, on the same side of the equation. So if you have something that appears to be a like term, one on the left side, one on the right side, unfortunately, if they're not on the same side, they are not by definition like terms. So this step wouldn't apply for those. They must either be all on the left or all on the right in order to combine them. If they are, combine them as is. You don't need to do opposite. So if it's being subtracted, you don't have to add it. You combine them with the signs that they currently have. Once those are taken care of, step 3 is you need to ask yourself whether or not the variable is on both sides of the equation. And the reason for this is often, as we see later on, the variable that we're solving for sometimes is scattered throughout. Might be a couple on one. You might have two x's on the left-hand side, an x in the parentheses on the right and an x outside the parentheses on the right as well. You never know where it's going to be. But at this point, if it's still on both sides of your equation, you need to move one of them so that it's on the same side. You can't get it by itself if it's all over the place. Now, I have a hint there for you. Maybe not a hint, I should say suggestion. If you have a variable on both sides, technically you can move either one by doing the opposite. But my recommendation is move the smaller of the two. And here's my reasoning for that. One of the things that usually trips students up the most are negative signs for whatever reason. They cause confusion when you're adding and subtracting. They cause even more confusion when you're multiplying and dividing if you're not comfortable with the rules that go with each. So by moving the smaller of the two variables, you're going to avoid an extra negative sign that you'll have to deal with later. Now, I occasionally have students come in and say, well, I always like to move everything to the left anyways. I always like my variable to move to the left. And sometimes that causes them to move the larger of the two. Here's the good news. It will still solve to the same answer. So if at some point you're like, you know what, I have an urge to do it a slightly different way, talk it out with me. Because as long as it's mathematically sound, I'm not going to be that picky. I just give recommendations so we can avoid as many headaches as possible. So quick summary real quick. Parentheses, if there are any, we distribute. Like terms, meaning they're on the same side of the equation, we'll combine them. If the variable is still on both sides, we try to move the smaller of the two. And once we've addressed those three new things, step 4 is get that variable by itself. By the time you reach step 4, what you should end up with is either a 1 or 2 step equation. Think about it. If you did the practice yesterday, you spent a decent amount of time solving 1 and 2 step equations. So if we can get to step 4, we're going to be in our comfort zone yet again. All right. So we can talk about it till we're blue in the face, but it's best to see it in action. And so like I mentioned here, we're going to see steps 1 through 3 separately before we throw them into the same equation. So we'll have 2 examples where we're going to see parentheses. So we'll use the distributive property, 2 for like terms, and 2 scenarios where the variables on both sides. We're still going to solve them all the way through, and then we'll get to the more interesting examples on the back. So for those who weren't here yesterday, I like to use a little guideline here. And what I have found is it makes it a lot easier to see where your left side ends and your right side begins. It also makes it easier when you're doing things to both sides, because sometimes I have students do the same thing twice on just one side. This visual cue pays off a lot. Anyways, right off the bat, what should catch your eye? Those parentheses. Anytime you see parentheses, you can do one of 2 things. Either inside, you can do something to combine or follow the operations. Unfortunately, 1 minus 2x are not like terms. Second thing is to use this distributive property that we just discussed. So what are we distributing here? So we'll do 6 times 1, which is 6. 6 times a negative 2x, which gives me a negative 12x. Bring down my equal sign. Bring down my 90. Again, that guideline, another thing that helps with is there's one thing that should never really move, and that is your equal sign. So by having that guideline there, you can make sure that it's always in the same place all the way through this problem. All right, parentheses are out of the way. By design, there's no like terms, and the variable's not on both sides. So we jump all the way to step 4, which is to get the variable by itself. So this is a 2-step equation like yesterday. What would you do next? Subtract the 6 from both sides. I got 2 questions for you. First off, why did you choose to move the 6 before the negative 12? Just a habit. So good news, you have a good habit. The reasoning behind it is that negative 12 is still too close to the variable. think of it as we're working from the outer shell, getting closer and closer to that variable until it's the only thing left. So we usually try to move the terms that are further from the variable first. Second question for you, Jay. Why did you choose to subtract it?
The 6 is positive.
The 6 is positive. And the good news is you didn't fall for a trick that sometimes some people rush into. Sometimes I have students see that they see the 6 minus the 12 and they think, oh, I see subtraction, I should use addition. But what does that negative sign or that subtraction sign belong to? The 12. If I'm not moving the 12, I don't care about that sign. I need to know the sign of the 6, which in this case is positive. So we do the opposite and use a negative. And remember, one thing about equations, we like them to stay balanced. So whatever you do on one side, you have to match it on the other. So on the left, 6 take away 6 is 0, which is great because now it's out of the way. I'm going to bring down the negative 12x that I haven't messed with yet. On the right, I'm going to have 90 take away 6, which I believe is 84. Is the variable by itself? Not quite. Sorry? We still need to divide by negative 12. And we're dividing because when you have a value right up next to a variable like this, that's representing multiplication. We do the opposite, which is division. So I get x equals negative 7. Good. I'll take it sharp. All right. So let's take a look real quick. If you still need me to come back at some point, let me know. I can certainly do that. But let's take a look at another example where the distributive property is going to come into play. Let me throw in my little guideline there. Just think of it. Just a path. Line it up because I want visually. I could technically. It's a good question. If I'm really good at it and I'm being really careful, I could keep my equal sign lined up without that. But if I'm in a rush or if I haven't had enough practice doing it, what I notice is my equal sign starts to kind of slide left or right. So what I have found helps a lot of students, myself included, putting a little guideline in there, even if it's just a very faint line with your pencil, is a nice visual cue to just kind of keep that equal sign from sliding around your page. It's a good question. All right, so again, what should catch your eye first here? Those parentheses. In this case, what are we distributing? A 5. So we'll get a 35v minus a 15. Perfect. Drop my equal, drop my negative 190. So again, by design, no like terms, the variable's not on both sides. So we again jump to step 4, get that variable by itself. What would we move next? That negative 15? And how would you get it to disappear on the left? Add it to both sides. It's all about the opposites. So the 35v is going to drop down, and I like to slide mine over closer to the equal sign just so there's not a bunch of extra space. And I can do that because I know the negative 15 plus 15 becomes 0, which disappears. Drop my equal sign. Negative 190 plus 15, I believe is negative 175. And hopefully someone out there isn't just taking my word for it. Hopefully people are keeping me in check as well, because I goof also. What's left to move? And how are you going to move that 35? Divide it from both sides because it is currently being multiplied. So we do the opposite, which is divide. The 35 divided by 35 simplifies to 1, which we know likes to hide. And what is negative 175 divided by 35? Negative 5? Good mental math. Oh, I appreciate the honesty. I would have had to use my calculator too here.
Yeah, I was gonna ask, were we allowed to use that on the notes?
Absolutely. Use a calculator. It's 2021. You can buy calculators.
All of my math skills, I don't like using calculators, so if you ask me why I pick something, it's either a forced habit of being yelled at by a math teacher or it's yes.
So what I would recommend, what I do personally is I have very weak mental math skills. So what I usually do is I try to do it in my head, but then I follow it up with checking on the calculator. So it strengthens that skill that I know is a little bit weaker, but it doesn't allow me to make mistakes because I still follow it up with checking. Again, if you just want to use a calculator, that's fine. What I don't want to see you do is try to do all these steps in the calculator because you're gonna lose some of those values along the way. Still write out those steps. I know you get tired of hearing math teachers say, show your work, but I'll tell you though, my reasoning for it is if you get the wrong answer, I just want you to be able to look at your own steps and say, oh, shoot, 5 plus 2 isn't 7. It is 7. It shouldn't be 8. And I wrote an 8. I don't want to just say, do it just because I want you to do it. Do it because then if you have the wrong answer and you still can't figure it out, you come to me, we can talk through it. Someone brought me their work yesterday and they had erased, and I said, hey, let's look at what you erased. I forget who it was. I don't remember. But someone had erased some of it, and I said, well, let's look at what you had erased there. And come to find out, it was just a few sign errors. Easy to fix if you can go back and look at them. So there are some problems you can get away with very little work, but that usually comes with practice. All right, second column here, all things like terms. So these are designed to really accommodate step 2 in the process. So right off the bat, I noticed there's no parentheses to worry about. Do I have like terms here?
Yes.
What are they?
-4, -6.
At -4p and -6p. And how do I know they're like terms? There's two things that they kind of have to.
They both have a variable, they're both negative.
One of them, yes, they both have the same variable.
Same side.
What was it? What did you say, John? So that wouldn't necessarily be a factor that we'd have to worry about because we could combine odds with an even. Yes, Toby?
They're on the same side.
They're on the same side. So the variable has to be the same. But not only that, they have to be on the same side of the equal sign. Think of that equal sign as being a wall. They can't see who's on the other side. They can only combine with who's in the same room as them. So again, we are combining, not moving. Earlier, when we wanted something to disappear and move to the other side, we did the opposite. I don't want to move anything here, so I don't mess with their signs. So when you combine -4 with -6, what are you going to get? -10. So combining those is going to give me a -10p, drop my equal sign, drop my -20, jump all the way to step 4, divide by that -10 on both sides. Oops. So the -10 divided by -10 becomes a +1, which we love to hide. Drop my equal sign. -20 divided by -10 gives me a +2. Did you have just the wrong
I
sign?
think yeah, because I have 2 as the answer and I got 10. That's for the equation.
But again, that's why we write those steps out, because then we can go back and say, where'd my number and where'd I lose
I
it?
added 6 on both sides. What did you do?
Ah, that's actually a really good question. So you said you added 6 to both sides.
So I combined.
So if you added this 6p to both sides, what would happen is it would appear over here on the right, but you could not combine that
I
6.
didn't do that. I did combine them. I guess it just messed up somewhere else. I'm not sure what I messed up with.
Well, we can check later.
Or just perish.
So let's take a look at the next one here. A little bit busier, a few more pieces kind of thrown in. Again, the key is to try not to get distracted by it. Do we have any like terms on this one? The 5 and the 8. Now I noticed that those don't have variables, but is that okay? Yes. So usually we say like terms have to have the same variable, but in having no variable, that's something they have alike as well. So the 5 and the 8 can be combined. But let me ask real quick, can I also combine it with the -3 since it also doesn't have a variable? They're not on the same side. So as much as they may have in common, because they're not on the same side of the equation, I cannot combine them at this point. So I bring down the -2a. What's that 5 and 8 make? 13. It's not attached to the a. The 5 and the 8 didn't have any a's. Bring down my equal, bring down my -3. Now we just get that variable by itself. Subtract 13. Real quick though, Jay, you had a look of confusion. Where'd I lose you?
Confusion is normal. I'm just gonna redo it and see where I messed up.
Okay, if you still can't find it, let me know. It's all part of the process. If you got every single one of these right the first time, I'd be worried. Because either one, you're just Googling the answers, or two, you've been placed in the wrong class. You probably don't need Algebra 1. You should be Algebra 2.
I subtracted 5 from 5.
You subtracted the 5? Okay.
I'm not used to having a whole like. I have the more enforced rule that if they have variables, they're the same, not necessarily if they're not.
Well, luckily we can add to that list of being the same. If they don't have variables, they can be combined as well. And what's nice about that is here in just a moment, I will have to move fewer pieces from one side to the other. Saves me just a little bit of work. So what you were doing was not wrong. It would have just given you an extra step. So I think Toby, you said subtract 13 from both sides.
Yeah.
So 13 take away 13 is 0 on the left. Leave me with just a -2a. Bring down my equal sign. -3 take away 13 is a -16. And what's left to move? Divide the -2 from both sides. +8. So the -2 divided by -2 is +1, which hides. -16 divided by -2, a lot of you are saying is +8. We're done. So far, we can now hypothetically solve problems where there's parentheses that need to be removed, or even problems that have like terms. Yes?
You get the same outcome if you get 5, 5, and 8.
It's a good question. I'll prove it to you real quick. So the question, for those who may not have heard, you don't have to do this. You guys can just watch real quick. Well, what did you do? Did you subtract 5 from both sides?
No, I'm talking about like if you, if you were to like say subtract 5 from both sides and then subtract 8 from both sides.
Yep. So think about that real quick before I do it. If you subtract 5 and then immediately following that subtract 8, how many you're actually subtracting? 13.
Yeah.
So you're going to do the same step. You just did it in 2 parts, whereas I combined them so I could move it all at once.
So it would just be faster that way.
It would be faster. I wouldn't say it's better. I would say it's 1 step faster.
Okay. Yeah.
So I won't even bother doing this then, since you already kind of spotted it. So again, I'm not going to be the guy here that says you have to do it exactly my way every single time, otherwise it's wrong. If you take 2 extra steps to do it, but it's mathematically correct, I'll say, great, that's really clever. Or, hey, you're doing a little bit more work than you have to. Have you considered doing this? And if you say, you know, I prefer doing it this way, I feel more comfortable with it. And if you are yielding consistent success from it, I'm gonna say, okay. I don't care if it takes you 2 extra steps if you're still getting the same outcome. So I'm not one of those teachers that says it's my way or it's wrong. I'm not the god of math. All right, last column here. So again, these by design have variables on both sides. So you'll notice, hopefully, there's no parentheses. Are there any like terms? What are you seeing?
7x and
7x and 4x.
Right now, you have to get the 4x.
So technically, no. I like that response because, yeah. Right. So by definition, if I was just looking at this as is, there aren't any like terms because the 7x can't see the 4x. It's on the other side of the equation. So there aren't any like terms, which is why we have this third step that says, hey, if your variable ends up landing on both sides. Oh, shoot. You just told me your name. Jacob. Jacob was alluding to the fact that we probably should move that 4x. That way we can then combine them.
Like generally speaking, like, because you asked, like, if there's already. So, I mean, I know it's not right, like, to solve with, but you were asking me to think, like, there's still 2x.
Right, but they're not like terms because they can't see each other. That equal sign is behaving like a wall. So by definition, they're not like terms until we can get one of them to the other side so they can see each other. Now, Jacob, quick question. Is there a reason you specifically chose the 4x instead of the 7x?
It's just the way I do it. I'd rather have x on left side.
I made that comment earlier. I don't think you were here yet. Some students really like their variable to be to the left side as soon as possible. And that's okay. And it's going to work out here. One of my suggestions typically, though, is if you can, I usually try to move the smaller of the two. And that'll avoid an unnecessary negative sign later on. Both ways are correct, though. But how would I move that 4x? If I want it to disappear from the right-hand side, I'd have to do the opposite. So I would have to subtract the 4x. But whatever I do to one side, I have to match it on the opposite side as well. And notice I went ahead and lined it up with that 7x that we're really hopefully itching to combine it with, because those are going to be the pieces that can combine. So on the left, 7x take away 4x gives me 3x. Drop down my -5. Drop down my equal sign. 4x take away 4x is 0, so it's gone. Drop down my -14. And then we've been here before. Now we just got to get that variable by itself. What's next? Add 5 to both sides. So the 3x is going to fall on down. -5 plus 5 is 0, which disappears. Equal falls on down. -14 plus 5, I believe, gives us a -9. Then last but not least, divide that 3 from both sides because we still need that 3 to move. So the 3 divided by 3 is a +1, which hides. -9 divided by +3 gives me a -3. There's that one. Now, I would recommend that if during the notes you find yourself still struggling to write neatly, a very strong recommendation of mine, I had to do it for myself personally before, I'd get some lined paper. I think I have grid paper, which works about as well, but get some lined paper to kind of keep your work in a neat setup. Again, sounds silly. You think, why does it matter how organized I am? Well, math is already a difficult enough subject for most people. Why add extra difficulty on it by not being able to read what you've written down? Last one on this side. This one I threw in here just for good measure. Try to cover all the varieties I can think of. Just a quick check though, hopefully we can agree there's no parentheses. Are there any like terms? No, because they're on opposite sides, or the terms that we would want to combine are on opposite sides. So that brings us to the variable on both sides. Now, Jacob, I would assume you'd want to move the negative 4a, is that correct?
Yes.
Which means you would add it, right? And you'd get a negative 1a on the left, which would be great. The very end, you're gonna have to divide by that negative 1 though, right?
Yep.
Which is perfectly fine. And if have you already done it that way?
Yep.
Great, leave it that way. If you are following my suggestion, however, and negative signs kind of are a little tricky for you, I'm gonna try to avoid it altogether. So we're gonna see if we can match Jacob's answer here by the end. Which one technically is smaller of the two, the negative 5a or the negative 4a? The negative 5, which tricks people a little bit because we think 5's bigger than 4, except when it's negative. Negatives work backwards than what we're used to. So technically, the negative 5a is the smaller of the two. But again, good news, if you moved either one of these here, you would still reach the same conclusion, so long as you're careful with your signs. How would I move that negative 5a? Yep, I'm going to do the exact opposite of what it's doing. So I'm going to use a positive 5a or add it to both sides. So the 9 is going to drop down. The negative 5a plus 5a is 0. The equal sign drops down. Negative 4a plus 5a, I can make a decision here. What is negative 4 plus 5? Not quite. Ours is going to be a, well, think about it this way. If you owe $4 and you earn $5, you pay off your debt, you got 1 left. So technically I can write this one of two ways. I can write this as 1a plus 5. But could I technically write this as a plus 5? I'm not going to tell you which one to choose. I would like you to choose the one you feel most comfortable with. If I leave the 1 there, at the very end, technically, I would divide both sides by 1. But does dividing by 1 do anything? No, it would just allow me to hide it. If I hide it now, I actually save myself a step later. If you need to see that 1 there, though, leave that 1 there. Take care of it the way you feel most comfortable. I personally am a little bit lazy. I hide 1s whenever I get the chance, whenever I don't need to see them anymore. Because now, what does this leave me with to move? The 5. How would I move that 5? Yep, subtract that 5 from both sides. Because our goal is still the same. We're still trying to get that variable by itself. It just so happened to land on the right-hand side with the way we did it here. 9 take away 5 gives me 4. Bring down my equal, bring down my a. 5 minus 5 is 0. Absolutely. I would take that extra step to write a equals 4 so the variable comes first. But Jacob, I'm assuming you got the same answer. Is that correct?
Yep.
Perfect. And that again is why I don't say you have to do it my way. There are actually multiple ways you could solve this. Some of them just take fewer steps than others. So, quick summary here, see if I can squish them on the screen. If we have parentheses, we can knock them out by distributing. If we have like terms, meaning they either have the same variable or have no variables, and are on the same side of the equation, we can combine them. And if we have the same variable on both sides, we can get them to get to the same side, we can move one of them so we then can get them by themselves. Now, so far, these still took, I would say, on average, 3, maybe 4 steps. Let's see what happens when we combine all these possibilities in the same problem. So all together now. So again, when you just look at it right now, it looks a little bit scary at first because there's a lot of pieces to keep track of. But you got to remember, I'm not asking you to just tell me the answer right now. All I'm asking you to do is take care of one thing at a time. First, take care of parentheses, then take care of like terms, then take care of whether or not the variable is on both sides, and then finally get that variable by itself. You do not have to do 4 things at once. You just got to do one thing at a time. But this is going to be where a little bit of guidance here with this guideline is probably going to pay off. What should catch our eye first? Parentheses. This time we do have 2 sets of parentheses, but I can go ahead and take care of both in the same step since they're separated. On the left, what am I distributing? At 2. So 2 times a negative 4n gives me a negative 8n. 2 times a negative 3 gives me a negative 6. And do I do the 2 times 2?
No.
Why not? So it's not included? So what do I do with it? Just drop it on down. Same with the equal sign. On the right-hand side, another set of parentheses for which we're distributing what? Okay, so what's negative 6 times n? Negative 6n. And then I heard, Jonathan, you said plus 24. Perfect. Did we just take care of all the parentheses? Step 1 is done. What's step 2? What do we look for next? Like terms. Do you see me?
Yeah. No. Yes.
Ooh, careful. So they do have the same variable. Unfortunately, the negative 8n and negative 6n are on opposite sides. Same problem. 2 and the 24 are also on opposite sides. But Toby, you seem pretty excited.
Negative 6 and 2.
The negative 6 and 2, however, are on both on the left side. Because they both don't have variables. Yep. So it's not about even or odd. It's not about their signs. It's about whether they have the same variable or not. And not having variables is the same thing as having the same variable. So I'm not going to touch anything else here. Negative 8n is going to drop down. What's negative 6 plus 2? Negative 4. So all I did was just combine those 2 like terms as is. Drop down my equal sign, drop down my negative 6n, and drop down my positive 24. So step 1, we took care of parentheses. Step 2, we just combined all the like terms we had. What's step 3?
Get the variable by itself.
We need to get the variables by, well, not by itself yet. Someone else said something else. We do need to combine them, but in order to combine them, we need to get them to the same side first. Because right now it is on both sides. Technically, we could move either. If we were sticking with the smallest, what is smaller, negative 8n or negative 6n? Negative 8n, because negatives work opposite of what we're used to. How would I make that negative 8n on the left disappear? Add it or make it a positive. But you got to do it on both sides. Notice I'm lining it up with the negative 6n because that's the only term that it has anything in common with. On the left, negative 8n plus 8n is 0. So it leaves me with just the negative 4 to bring down. Bring down my equal sign. Negative 6n plus 8n. I believe it's going to give me 2n. And then I bring down the 24 that I didn't do anything with yet as well. So again, to summarize, we took care of parentheses first. Then we took care of like terms. And then we just took care of the variable on both sides. Those are the only 3 new things I taught you today. Because now where we're at is just another 2-step equation, which was yesterday's topic, part of yesterday's topic. All that's left to do is to get that variable by itself. Make sure you're focused on the right side. Well, I should say the correct side, which happens to be the right side this time, because that's where the variable's at. What are we going to move next? That's why I said focus where that variable's at.
Subtract 24.
We'd have to subtract the 24. So if the variable's on the right, that's the side I'm peeling things away from. So I'm subtract the 24 from both sides. On the left, -4, take away 24 is going to give me a -28. Bring down my equal sign, bring down 2n. 24 minus 24, of course, is now gone. What's left to move? The 2. To move it, we're going to divide both sides by 2. -28 divided by 2 gives me a -14. 2 divided by 2 simplifies to a +1, which allows me to hide it. Last but not least, good practice, make sure your variable does come first in your final solution. That's actually going to help us out with what we learn tomorrow. So again, significantly more steps than what we did on the front. But when you just take it one line at a time and address only one piece at a time, eventually it's going to start to fall into place. And eventually it's going to start to look like something you're more familiar with. Let's take a look at this next one. Same idea, a little bit different. What should catch our eye first? Parentheses. We do again have 2 sets this time, so we'll handle each of them in this line. Is there anything I can do with the left-hand side yet? No. We will do something later, but right now we're just thinking parentheses. So if it doesn't have anything to do with parentheses, I'm just bringing it along for the ride. On the right is where we have both of our sets of parentheses. What's the first thing we're going to distribute here? The -4. So -4 times n is going to give me a -4n. -4 times 8 is going to give me a -32. But then I get to this second set of parentheses, and it's not immediately clear what I need to distribute because it's partially hiding. Sorry, I heard half of it. There is a 1 hiding there. Technically, now that means it's a -1, and that's exactly what I'll distribute. So -1 times n is going to give me a -1n, and a -1 times 8 is going to give me a -8. Did we take care of all the parentheses?
Yes.
Absolutely. What comes next? Like terms. This one's a little bit different because I think there's multiple sets of like terms. Let's just start on one side. Let's start on the left. Any like terms on the left? 3n and 2n. They have the same variable and they're on the same side. So I'm going to go ahead and combine them to make 5n. Bring down my equal sign. On the right-hand side, do I have any like terms here? The -4n and the -1n. And just so my eyes can differentiate that this is not being combined with the terms on the left, I'm going to put 2 lines underneath. This is a little trick I use personally. -4n and -1n would be a -5n. But the -32 and the -8 are also like terms. So again, this looks a little messy, but if you were to go back later and look at it, it's kind of visually appealing. You said the -32 and -8 make -40? Good. So this time, like terms was a big process. We actually had 3 different sets of like terms. But again, why I choose. So like terms took a little bit of extra work this time because of the 3 different sets. But now that we've carefully combined what we can, where we can, we're getting closer to that end goal. So we took care of parentheses. We just combined like terms. What's the third thing we need to check for? Got to get the -5 into the other side. And that's because we really don't like to have the same variable on both sides, because they're not like terms, because they're not on the same side. So to fix that, we move one of them. Now, if we're sticking with that smaller idea, -5n would be the smaller of the two. So the opposite would be adding 5n or positive 5n. So on the left, 5n plus 5n gives me 10n. On the right, -5n plus 5n is 0, which is gone. And I drop down my -40. Well, then we're in luck here because we're still trying to get the variable by itself, but this time we're left with a 1-step equation. What's left to move? Divide both sides by 10. So the 10 divided by 10 simplifies to a 1, which we hide. Drop my equal sign. -40 divided by 10 gives me a -4. So even if everything is applied, so long as you only worry about one step at a time, it will slowly fall into place. So there's one last thing I'd like to introduce to you today, and it only adds one tiny extra step. I promise, it only adds one tiny extra step. They look like fractions, but when you have 2 seemingly fraction-like objects that equal to each other, they have a special name called a proportion. And there is a trick that allows you to take a proportion that looks like 2 ugly fractions and rewrite it so it looks more like the equations we've just spent time today solving. So if I can rewrite it into something we just spent a lot of time practicing, it'll start to feel more comfortable. So to solve proportions, you must first use a process where we cross multiply, and I'll show you here in just a moment. But then it says the steps that follow are the same steps we used for solving multi-step equations. So here's the first one. We have a minus 10 over 2 set equal to 6 over 3. Now, there's a catch because the numerator here on the left does have 2 pieces. So when I move that numerator around, I do want them to stay grouped together. Can you think of some grouping symbols that we're very comfortable with, hopefully? Starts at the beginning of the order of operations. Parentheses. If I want the a minus 10 to stay together, why not visibly group them together with a set of parentheses? Well, because I'm getting ready to do this neat little trick called cross multiplication. Now, I still want my equal sign to try not to move. So I'm going to set my little guideline in place. And then the name kind of suggests what we're going to do. We are going to multiply across this equation. We're going to take one numerator and multiply it with the opposite denominator. So it's kind of like a diagonal pairing here. I'm going to multiply the 3 with the a minus 10 and then go the opposite direction, and I'm going to multiply the 2 with the 6. That's it. That's the only difference, is that cross multiplication, because now This is just another multi-step equation. And hopefully, what's the first thing that should catch your eye? Parentheses. Technically, I did use them on both sides. We can still use them the same way we use any parentheses. On the left, what am I distributing? 3. So 3 times A is going to give me 3A. 3 times a negative 10 is going to give me a negative 30. Drop my equal sign. On the right, if I distribute this 2, what's 2 times 6? 12. So we took care of parentheses. Are there any like terms? No. Is the variable on both sides? No. So all that's left is to get the variable by itself. What would you move? Add 30 to both sides. So we get 3A equals 42. And then last but not least, we divide both sides by 3. And we get A equals 14. That doesn't sound right. Is it?
It is, yeah.
This is why I have you guys to check me. So again, the only difference between a proportion and a regular multi-step equation is you do that cross multiplication first, so it doesn't look like fractions anymore. That way it can follow the same 4 steps we used for our other equations. Let's try one more, and then you get to try the rest on your own on the assignment. My little guideline in here. This time we do have both numerators carrying 2 pieces. So to make sure each of them don't accidentally get mismatched, I want to make sure they stay grouped with each other in this cross multiplication phase. I'm going to go ahead and take that first numerator and multiply it with the opposite denominator. So that's 8 times x minus 7. And then for the other side, I go the opposite direction with the 4 times the x minus 3. With the cross multiplication out of the way, we just go right back to our 4 steps. Whoops. What should catch our eye first? Those parentheses. 2 sets, we'll just take care of them one at a time. On the left, I'm going to distribute an 8. 8 times x gives me 8x. 8 times negative 7 gives me a negative 56. Bring down my equal. On the right, I'm going to distribute my 4. 4 times x is 4x. 4 times negative 3 is a negative 12. Any like terms? Close. It is tempting. But unfortunately, they're on opposite sides. Well, the 12 and the 4x wouldn't work because one has a variable and one does not. So again, remember, you won't always use every one of the 4 steps. Sometimes you'll check for them, but you'll skip it. Step 3 does apply here, though. The variable is on both sides, so we would move one of them. So if I were to move the 4x by subtracting it from both sides, that would get it to the same side, which will make getting it by itself a whole lot easier. I wouldn't yet, and here's the reason why. I would only worry about the variable first, because that's really my main focus this whole time. Everything else will slowly start to fall into place. Once I get that variable to the same side, so 8x minus 4x is 4x minus, 56. By getting that variable to the left this time, I hopefully now see that the negative 12 is actually already out of the way. Because my variable is now on the left-hand side. That's going to be the side I move the rest of my pieces from. Then I ask you real quick to pause and ignore me while I take care of my minor OCD.
56 both sides.
So we're trying to get the variable by itself still, so we'll add the 56 to both sides. Don't know why So negative 56 plus 56 is 0. Leave me with 4x. You said negative 12 plus 56 is 44. Sounds good to me. Last but not least. Yep, divide both sides by 4. Gives us x equaling 11. Now, I will be the first to admit that I kind of made a mistake. 2 examples I gave you for proportions came out to be fairly nice numbers, didn't they? That was a shame on me moment. I'm here to tell you, because of the fact that they start off looking like fractions, the process that we use, it is actually fairly common that proportions, when you solve them, will end up being a fraction or a decimal at the very, very end, meaning you'll get something like 5 divided by 7 or something like that. That is okay. Normally, I have to make this announcement because normally when students get a fraction or a decimal when they're solving an equation, they panic for a moment thinking they did something wrong. On proportions, it's actually fairly common to get fractions or decimals. So the good news is those answers are going to be at the back as well. So if you're worried for a moment, you can check there to see, is it actually supposed to be this unusual answer?